All right, I'm going to do the first part of the 2.3 just here. Instead of doing it on the whiteboard, I'm going to do it here with my iPad just so we can see the calculator. It's a little easier to show here. So this first part is just about how you take the derivative with the calculator. So some calculators have what we call a computer algebra system, and they can actually find the derivative of an equation. That's what it means by symbolic form. But that's not allowed. You can't, excuse me, sorry. You're not allowed to do that on the AP test. And so it's not going to be helpful to be able to do that. What we're going to focus on is finding the derivative at a specific point. And you can do that with most graphing calculators, and I'm going to use a TI-84 to show you that. Okay, so look at number 1 down here. It says f of x equals x cubed plus 3 to the x, and it wants me to find f prime of 2. So that's what we can do on the 84, is we can find the derivative at a specific point for a specific x value. So here's how we do that. If you look at your calculator, right down here is the math menu. So if you hit math, and then if you scroll down, number 8 says n derive. So you can either hit 8 or scroll down to there. When you do, it comes up like this, and it has d, and we're just going to put an x in there. All right, we're going to take the derivative with respect to x. Sorry about that, Bell. And then make sure you put the equation in terms of x, because we did d dx, okay, derivative with respect to x. So we're going to put in there x to the third plus 3 to the x. Whoops, forgot my plus sign. Okay, once you have your function here, we're going to come over to x equals, and that's where you're going to put in where we're trying, that line right there means to evaluate it when x equals. So we're going to evaluate when x equals 2. That's what we're plugging into our derivative. So we're going to put a 2 in there, hit enter, it thinks for a second. There's our answer. So f prime of 2 is 21.887, making sure we go out 3 decimal places. Okay, it's as easy as that. So the calculator can always find derivatives at a specific point. Go down to number 2. It has g of x equals the ln of x cubed minus 3. Let's find g prime of 2 first. So I'm going to go math, n derive, d dx, and we're going to put in our function, which is the ln of x squared minus 3. Oh, I need my end parenthesis there, so make sure I do right there. Make sure you have an end parenthesis. Okay, and then I'm trying to find out when x equals 2. We're going to put 2 there, hit enter. There's my first answer. So if I go 3 decimal places, it's still just going to be 4. Something that could be helpful is if you want to, I have to put 4 in, g prime of 4 in now. If you scroll up to it and just hit enter, you can pull that up again, and then you can type in over the 2, put a 4, and then hit enter, and there's my other one. So I got 0.615, 0.615. There's another way to get those answers too, so let me show you the second way. The second way is you go into the grapher, so go into y equals, and enter in your function. So I have the ln of x squared minus 3. If you need to pause it and enter that in, you can go ahead and do that. I'm going to go to zoom standard, graph it, and it ends up looking like this. Now, we want to find g prime of 2. If you go to the calculate menu, we've used that before to find zeros right there, so hit second, trace. If you go down, right, we see the dy dx. We know dy dx means find the derivative. So hit dy dx. It comes up like this. You have to type in the x value you want to find it at. So let's type in 2 again, hit enter, and it comes out to be 4.00. That's the same thing as we got over here, right? So let's do it. You guys pause it, try it again, plug 4 in using the calculate menu. You should have gotten, right, second calc, dy dx, type in 4. Should have gotten a 0, right, same answer as it comes out to. So that's another way you can find a derivative with the calculator, is you can graph it and find it through there. Now the second part of the equation actually told us to graph g prime of x. So I want to show you how to do that. So go back into the y equals. I've already got the original function up there, but we want to graph its derivative. So scroll down, and this is how we do it. I hit the math menu again, right? Hit math. Okay, I go down to n derive again. Enter. D dx again. Okay, right there in the parentheses, we need to type in, you can do one of two things. We can retype the ln of x squared minus 3. Or if you want, since we already have it up in y1, right here there's a button that says vars. So if you click on that, and you go over to y variables and hit enter on number 1 under function, and it brings up that y1. If I hit enter on that, it puts the y1 there, which means it will use that equation up there and I don't have to retype it. So that's a quick trick on how you can avoid having to retype it a bunch of times. Okay, come over, x equals. This is really important. This is the part we get most confused on. If I were trying to find the derivative at a specific number, I'd plug the specific number in there. But if I'm trying to graph a derivative, I want it to find it for a bunch of different x values, and then I want it to plot those points and connect them and draw the graph. So the way we make it do that is we just put x equals x. If I do that, it will graph the derivative. So let's go ahead and hit graph. The first graph should still be there. There's the original graph. And the graph of the derivative is coming up there in red. Now I want to point out the connection between these. If you follow that graph, right, this is my original one up there. As you go along, the slope is negative all the way across. Up here, it's pretty close to 0, but as you go along, it's getting to be a steeper, a bigger negative number. The slope's getting steeper on the negative side. So look what happens to the values of my derivative. It's pretty close to, it's negative, but pretty close to 0. But as I get closer, you can see how each of those y values is a slope. So right here, the slope is really steep, and so you get really big negative numbers. Over here, same thing, the slope is positive all the way across. So look at my derivative, it's always positive. Now right here, the slope is really steep, so I get these really big numbers. But as I go across, the slope's getting closer to 0. So you can see how my derivative comes down and gets closer to 0 across there. So just make sure we're making that connection, right? The derivative is the slope of the original function. So if I find the y values of the derivative along here, that would tell me the slopes of each of these x values up here. Okay, that's it for the graphing part. The rest of it I'm going to do up on the smartboard, so I'll make a separate video for that portion of it. Thanks, guys.